Hello everyone, welcome to the new session of pH and buffer solution. So we are studying the biochemistry and along with the pH and buffer solution, it won't be going to complete our any biochemistry, right? So we will study about in this session about the buffer solution. What are the buffer solution? Then different types of buffer solution. Okay, so they can be acidic buffer or the alkaline buffer. So we will see some of the examples of this. Now there will be again the preparation of buffer solutions, and then we will study about the Henderson-Hasselbalch equation. So all these things we are going to study about in this particular session. So let us start. Buffer solutions. An acid-base buffer solution is a solution that maintain its hydrogen ion concentration, means pH. So if we talk about the hydrogen ion concentration, then actually we are talking about its pH. Okay, so with only minor changes when diluted or when a small amount of acid or base is added to the solution, the buffer of the solution get changes. So this is suppose a solution in a beaker, right? And it is having some amount of hydrogen ion concentration. Now you add some acid in it, or you add some base in it, or you add some water in it. This hydrogen ion concentration that going to be changed. So there is a change in the buffer solution. So the buffer solution used in fermentation, food preservatives, drug delivery, electroplating, printing, the activity of the enzyme, and the oxygen carrying capacity of the blood. So in the living situation only, or you can say in the cell, right? So what is happening in the cell? Activity of many enzyme, oxygen carrying capacity of the blood. So all these phenomena is occurring where? In the blood. So the blood is having its own buffer. Okay, but if we are talking about the fermentation, okay, the fermentation that is normally taking place in the environment with the help of microorganism, and sometimes we want to do some fermentation to prepare some food materials, okay, for some food preparation. So there also we try to maintain this fermentation. So there the buffer solution you can see. Food preservative, you are using some food preservative, there also you are having the buffer solution. Drug delivery, electroplating, printing, all these activities are having the buffer solution. And they require a specific hydrogen ion concentration to function properly. So every example, whatever the example we are talking about, it is having what? It is having a particular hydrogen ion concentration. Means every buffer solution is having its own hydrogen ion concentration. It means that the buffer solution is having its own specific pH. The solution of a weak acid and its conjugate base, or a weak base and its conjugate acid, have the ability to maintain the pH and are therefore known as buffer solution. So every solution, suppose solution of a weak acid and its conjugate base, so acid and its base, right? A weak acid or conjugate base, or weak base conjugate acid, have the ability to maintain the pH, and therefore the solution which are maintaining its pH, they are not changing its hydrogen ion concentration at a particular point, then it is known as buffer solutions. Acidic buffer and alkaline buffers are the two primary types of buffer solution that can be broadly classified into two categories. So there are two different types of buffer solution: acidic buffer or alkaline buffer, right? So we will see how they are known as, like sometimes they are known as acidic buffer and sometimes they are known as alkaline buffer, how they got its name. So that we are going to study about, right? So the acidic buffer or alkaline buffer are the two primary types of buffer solution, right? So these are the two broad category of the buffer solution: acidic buffer and the alkaline buffer. So let us see this. The first one is the acidic buffer. These solutions, as the name implies, are used to keep acidic environment intact and healthy, right? So acidic buffer means the solution is maintaining its acidic environment. The environment of the solution is acidic, and that is why the name to that buffer solution is given as acidic buffer. Okay, pH of an acid buffer is acidic. So if you note down the pH, so you know that pH start from here to 0 to 14, right? And at the mid 7, that is showing the neutral, and it here it will be 6 5 4 3 2 1 0, and here it will be 8 9 10 11 12 and 13. So this is a strong base, right? And here at one position, then here it will be a strong acid. So magnitude, in the case of lower magnitude, that will be showing the strong acid, higher magnitude showing the strong base. And if you see here 7 is the neutral, then you start moving to here, then it will be slight acid, weak acid, you can say weak acid. And here from 7.1 7.2 it will be weak base. Okay, so the pH of an acidic buffer is acidic. It means that the pH acidic buffer should be from this less than 7. Okay, and it is made by mixing a weak acid and its salt with a strong base to form an acidic buffer. So how you make a acidic buffer? So suppose you are taking any weak acid, okay, and its salt. So you have to take the weak acid and its salt as well, and with a strong base, add a strong base to that, and that solution will be acid buffer. The pH of an acetic acid and the sodium acetate. So this is the salt of acetic acid. This is the acid, and this is the weak acid. This is the weak acid. Sodium acetate is the salt. Okay, and aqueous solution is 4.74 when the concentration of the two acids are equal. So this is what? This is showing the acidic pH example. The pH of these solution is lower than 7. So 7, less than 7, it will be considered as acidic buffer. Essentially, these solutions are composed of weak acid and a weak acid salt. So you have to take two things, weak acid as well as its weak acid salt. Like in the previous case, acetic acid and sodium acetate, it has been taken. So both the sodium acetate is also the weak acid salt, whereas acetic acid is the weak acid. Now sodium acetate and acetic acid pH, that is 4.75, for example, are the two acid that can be used as a acidic buffer solution. So here you have to take two things. One is the weak acid. So here it is taken as the weak acid, acetic acid, and its salt and its weak salt, that is sodium acetate, right? So its pH is 4.75. For example, the two acid that can be used as an acidic buffer solution. So these two can be used as an acidic buffer solution, and its pH will be 4.74. That will be balanced, and that is why it is called as buffer solution. And its pH is 4.74. That is why it is called as acidic buffer solution. Acidic buffer. Now, we will talk about another type of buffer that is called as alkaline buffers. So these buffer solutions are used to keep the fundamental condition in a place, and it is possible to create basic buffers in the same way. The one which has been used to create acidic buffer, the same criteria will be used to make the basic buffer. So it is possible to create a basic buffer by mixing a weak base and its salt with a strong acid to produce a basic pH. So you are required two things: weak base and its salt. So the pH of ammonium hydroxide. So we are taking this ammonium hydroxide, which is a base, and ammonium chloride. This is a salt. This is a salt of, this is a base, and this is a salt of this weak base. And this aqueous solution is 9.25 when the concentration of the two acids are equal. So moreover, the pH of the solution is greater than the 7. So it is greater than the 7. That is why it is considered as what? It is considered as alkaline buffer. The weak base, and the weak base salt are present in these formulations. So here ammonium hydroxide, right? Ammonium hydroxide and ammonium chloride. This is the weak base salt. So the alkaline buffer solution, such as a mixture of ammonium hydroxide and ammonium chloride, pH 9.25 is an example of the base. Okay, on addition of acid and base. So when acid is added, the acetate ion removes the acid release protons, forming an acetic acid molecule. So here hydrogen ion is added to, from added acid CH3COO minus ion. So it will form CH3COOH from the buffer solution. Okay, so if an acid is added, so you have added the acid, the acetate ion remove the acid. So this is the acid. So now how it is removing? Because it is acid, means it is having the hydrogen ion concentration. So this hydrogen ion get attached to this buffer, right, CH3COO, and it will remove the acid. So it will form CH3COOH, that is acetic acid molecule. Now in the same way, when the base is added, hydroxide produced by the base. So this is due to the addition of base. This is due to the addition of base. Okay, hydrogen ion will get attached to hydroxyl ion, OH minus ion get attached to the hydrogen ion from the added base, and it will form H2O, right? So it is taken from the hydrogen ion, resulting in the formation of water. So this happens in the case of adding of a base. If the dissociation constant, means preparation of buffer solution, how to prepare a buffer solution. If the dissociation constant of an acid, that is pKa, and the base pKb are known, it is possible to prepare a buffer solution by controlling the salt acid, means salt acid acidic buffer, or salt base ratio, that is the basic buffer, respectively. So you have to know the pKa, means the dissociation constant of the acid, and pKb, that is the dissociation constant of the base. These two things, then you can make the this salt acid or salt base ratios respectively. So this type of solution is prepared by mixing weak base with their corresponding conjugate acid, or by mixing weak acid with their corresponding conjugate base, as previously discussed. Okay, so this is very, very important to prepare a buffer solution. So if you want to prepare a buffer solution, then you, in two things you can do. Either you can take weak acid and its corresponding conjugate base, okay, or you can take weak base with corresponding conjugate acid. So both the things you can do. A good example of this method of preparing the buffer solution is the preparation of phosphate buffer by mixing HPO4 2 minus ion and H2PO4 minus ion. Okay, so these two things means phosphate buffer. This is to create the phosphate buffer. Okay, so this is a method to preparing the buffer solution in the preparation of the phosphate buffer. So either you have to take HPO4 2 minus ion, or you have to take H2PO4 minus ion, which is shown in the figure below. Okay, this solution maintain the pH 7.4 at all the times. So here you can see Henderson-Hasselbalch equation, preparation of acid buffer. Now we will talk about the preparation of the acid buffer. An acid buffer solution containing a weak acid Ha and a salt Ka combining with the strong base. So if you are taking the weak base, then you have to take the strong base. Bb is considered KOH. It is possible to write down the equilibrium as HA, that is the weak acid, with water. It gives you H plus and A minus ion. Now the acid dissociation constant, that will be hydrogen ion HA, H plus ion, A minus ion upon HA. This is the dissociation constant. Okay, so first you will take the weak acid while adding the water, it get dissociated, and this is the reversible. So this you will get the hydrogen ion concentration and you will get the minus A concentration. Okay, and if you write the acid dissociation constant, then it will be written as Ka, that can be written as hydrogen ion concentration, okay, A ion concentration, anion concentration upon Ha. Okay, the pH of an acid buffer equal to pKa, that is salt upon acid. Now consider the case of a base buffer solution that contain a weak base. Now we will talk about the preparation of base buffer. Okay, so here you will take the weak base and its salt Ba in the presence of strong acid, just opposite. There we were taking weak acid, then here we were taking strong base. But if you are taking the weak base to prepare a base buffer, then you have to take the strong acid. So as previously stated, pOH can be calculated. The pOH of the basic buffer can be calculated as pKb plus log salt concentration of salt upon concentration of acid. The pH of the basic buffer can be calculated as pKa minus log salt concentration of salt upon concentration of acid. The Henderson-Hasselbalch equation can be used to. So what is the use of this particular equation? This equation is very, very important. So where all this equation is used to calculate the pH of a buffer prepared from a mixture of the salt and weak acid base. Okay, so it is used for calculation of the pH of any buffer prepared. And how this buffer is prepared? From the mixture of a salt and weak acid or weak base, right? To determine the value of pKa, so dissociation constant of an acid, so this is also used to determine the value of the pKa, that is the dissociation constant of any acid. So this Henderson-Hasselbalch equation is used for that purpose also. Prepare a buffer solution with appropriate pH. So this is also used to prepare a buffer solution. So if you want to make a buffer solution, then you can use this Henderson-Hasselbalch equation. But it has some limitations as well. This Henderson-Hasselbalch equation is having some limitations. So let us know what are those limitations. The Henderson-Hasselbalch equation cannot be used with strong acid or base, either strong acid or strong base, because of the nature of the equation. This is one of the limitation of this particular equation. pH maintenance. So if you are doing any type of reactions, and you all know in natural environment also, and even in the cell, there are so many biochemical reactions are taking place, and all the biochemical reaction that are taking place is having a specific pH, means the pH is very very important. So consider the following example of a buffer solution containing sodium acetate and acetic acid in order to better understand how the buffer solution maintain a constant pH. Right, so the pH maintenance is, if you are studying any type of reactions, and that reaction take place at a specific pH, so your buffer solution must maintain at that particular constant pH. So this is very very important. So pH maintenance is very important. uh, this example illustrates how almost completely the sodium acetate undergoes ionization, whereas only a weak amount of ionization occur in the case of acetic acid. So let us see, this is CH3COOH. It dissociate in the hydrogen ion and as well as the acetate ion, CH3COO minus ion and hydrogen ion, right? It get dissociated, and CH3COO NaSUP, and it will give you the CH3COO. So in the presence of a strong acid, right, the hydrogen ion combine with the acetate ions, forming the weak ionized acetic acid, resulting in the negligible change in the pH of the surrounding environment. And in the absence of strong acid, the pH of the surrounding environment remains constant. Upon introduction of a strongly alkaline substances into the buffer solution, the hydroxide ion react with the acid that are already present in the solution. So this hydroxide ion should be present with the acid that are already present in the solution, whatever the acid solution is there, right? So hydroxide ion has to present with the acid, resulting in the formation of what? Water molecules. Okay, so the hydroxide ion react with the acid to form the water. So this acid is giving what? This acid is giving hydrogen ion, right? Hydrogen ion and hydroxide ion, which is coming out of from the any base you are adding, right? So that will join together and it will form the water while the pH remains unchanged. Okay, so in this way the pH can be maintained. So what will be the conclusion? The conclusion is this: pH buffer, also known as hydrogen ion buffers. Okay, what is pH? pH is the hydrogen ion concentration. And what is pH buffer? Hydrogen ion buffer. Okay, are the aqueous solution that have traceable pH value and whose pH value changes only slightly when small amount of acid or base is added. So it change very slight because it has to maintain to any reactions to takes place. Okay, so the pH buffers are typically composed of a conjugate base and a weak acid, and which work together to absorb excess of hydrogen atom from the solution and maintain the stable pH value in solutions. As a result, they are effective for calibrating the electrochemical potentiometers for the pH measurement and with a low level of uncertainty, thereby improving the traceability. So this can be calibrated, this can be traceable, right? As because you know the electrical potentiometer for any pH, right? That can be measured with low level of uncertainty, means slight modification can be there, but yes, it is approximate. So this is improve the traceability. So this is all about this session. Thank you very much.